Now we will discuss the waveforms for the half wave controlled rectifier. The first one is the waveform at the input side. This V is equal to Vm sin omega t. It is sinusoidal in shape, and if we consider the corresponding output, it is for this interval 0 to alpha. No output is obtained at output, but it conducts only for this interval alpha to pi. It is because the gate signal was not applied before this angle alpha. The angle was applied at this instant alpha. So when the gate is triggered at this angle alpha, only then the output this thyristor will start to conduct, and output voltage will follow the pattern of input waveform. This is the waveform that is being obtained at the output. You see that although for this time for this interval 0 to alpha, certain voltages were starting to develop across this thyristor, but the output voltage was not obtained. It was because this thyristor was not operating. Although it is in forward bias, but since no gate signal was applied before this instant alpha, hence this thyristor was not conducting. That is, it can be said to be operating in forward blocking mode. And the output waveform across this resistor is also similar to that of the output voltage obtained. Since the output load over is resistor, hence the current at output will follow the waveform of the output voltage. If we discuss the voltages appeared across the thyristor, so for this time period 0 to alpha, the waveform that will appear across this thyristor is something like this. And when the gate is triggered at alpha, then the thyristor will start to conduct, and the voltages across this thyristor will ultimately become 0, and then in the negative cycle will come, and the polarities will be reversed across this thyristor, that is positive on this side and negative on this side. Then this thyristor will be in reverse conducting mode. The average output voltage can be obtained by integrating this quantity voltage Vm sin omega t over its time period alpha to pi. Since this thyristor is conducting from alpha to pi, so it will be integrated over its time period alpha to pi. And see that if we consider that the gate is being triggered at alpha is equal to 0, in that case we will obtain VDC is equal to Vm over pi. That was in case of uncontrolled rectification. And the RMS output voltage similarly can be obtained by scaling this quantity and integrating over its time period and then its square root. Now its analysis with an RL load. In this analysis we have the similar circuit. An input signal is applied over here. Thyristor T1 is present in our circuit, and we have an RL load. And this is the first case in which we are considering that there is no freewheeling diode. So we will see what kind of waveforms will be obtained at output. The supply voltage waveform is sinusoidal, and the corresponding gating signals are shown by this. So when this pulses will be applied to this gate, at that from that starting from that instant, our output voltage will start to follow the output. But if we see the output voltage, it also goes into this negative half cycle, and it operate for angle up to beta. Again the reason is same, that there are certain charges or certain energy being stored by this inductor, and when the current in our circuit suddenly drops to 0, this inductor will oppose it and will force this thyristor to conduct beyond this angle pi,